In section 5.1, we're just starting to look at systems of linear equations, which is just having two or more linear equations using the same variables. Typically, that'll be x and y. Um, a solution, so we're going to be working on solving these systems, is a point or an ordered pair that's a solution for each equation in the system. So if I had a system with two lines, the solution would be the point that's on both lines or the intersection point. Um, you'll also see the term break-even point as well. So when we solve these, um, today we're just going to be focused on doing that by graphing. And you want to make sure that all equations are in slope-intercept form just to make things a little bit easier on yourself. So making sure that you have y isolated by itself so that you can use slope and y-intercept to quickly graph your lines. Before we go into graphing, let's talk about what makes a point a solution to a system. So how do I know if a point is on the line? Well, if I substitute and check to see does it result in something that truly is equal, then I know that that point is one of the points on this line. So remember with coordinate uh, pairs, the first number is x, the second number is y. And so that means we can replace x with 3 and we can replace y with 1. So that first equation would be 3 in place of x, 1 in terms of y. And then let's see, is this equal on both sides? Well, 3 plus 1, that's 4. Does 4 equal 4? Yes, it does. So that's true. Let's try that for the second equation. Again, substitute 3 in place of x and 1 in place of y. So 2 times 3, remember we want to multiply first, that's 6. And 6 minus 1, well, that's 5. Does 5 equal 3? It does not, so that's false. So that tells me that that point, 3, 1, is not a solution. It's not a point that's on both lines. So if the given point that we're checking doesn't work for both lines, then we know that it's not a solution to the system. If it works for one but not the other, then it's not the intersection point um, or the solution. So try the same thing with um, 2 and 3, and then check answers here in just a minute. So trying number 2, I have 1 for x, 3 for y. So when I substitute that into both equations, 1 for x, 3 for y, 1 for x, 3 for y, I'm here. 1 minus 3, that is negative 2. So negative 2 does equal 2, so 1, 3 does work for the first equation. When I put it into the second equation, first I need to do 2 times 1. That's 2. And then when we add 3 for y, 2 plus 3 is 5. So we end up with does 5 equal 5? That works as well. So this 0.13 works for both equations. So yes, it is a solution. When we do the same thing into both equations with number 3, remember 2 is x, 0 is y. So for both of these two equations, we're putting a 0 in for y. And then I'm substituting a 2 in for x. So y 0 equals 2 minus 2. Well, 2 minus 2 is 0. So the first equation works, 0 equals 0. When we do that with the second equation, 0 equals negative 3 times x, or 2, plus 6. Negative 3 times 2 is negative 6, and negative 6 plus 6 makes 0. So yes, that point works for both equations. So 2, 0 is a solution. Next section, you have a pre-made graph, and it says solve the system. So what that means when we say solve the system, that's just asking you to find the intersection. So for number 7, I can see right here is where the two lines intersect, and that is at the point 2 for x, -2 for y. There's my answer. That's my solution. When it says check your solution, that means that we could go back up to what we did here and substitute that point 2, -2 into both equations to double check that it works. That's more a step that you'd want to do when you've made the graph by hand. When they give you a graph, you can assume that these lines are all accurate. So try the next two. Make sure that you're putting the x coordinate first. So second example here like that, I can see my intersection is right here. That is left 1 and down 3, so -1, -3 is my solution. And for number 9 here, that solution is at 4, 2. All right, so let's make some graphs here. With the first couple, we can see, or I can see that these are in slope-intercept form. So I'm looking at y equals mx plus b. You guys already know how we can graph these. We start at the y-intercept. So this first line I'll do in black would start at 3 on the y-axis. There's a -1 for slope. So that first equation, I'm going down 1 to go right 1. So down 1, right 1, down 1, right 1, down 1, right 1. So there's my first line. A straight edge is really helpful for these. You might want to make sure that you're using something straight to draw your lines. I'll do the second line in red. So again, that's a 1 in front of x. If there's no number, it's implied that it's a 1. This would start at 5 on the y-axis, and it would move up 1 to go right 1, considering that it's positive. So up 1, right 1 starts to take me off of my graph, but I'm moving away from the other line. So let's continue that pattern going down and left. And then I can see here's my intersection point. Now, if you're doing these by hand, you want to make sure that you use the slope to make sure both of these lines are going to intersect at a point. Sometimes it'll be close to one. Use that slope to make sure they both contain the same point. So I can see right there is my intersection. So there's my solution, is that point right there. That is at -1, 4. So try number 11 and see how you do. So looking at number 11, first line starts at 2 on the y-axis, and it has a slope of +1 over 2. So up 1, run of 2, up 1, run of 2. My second line starts at 4 on the y-axis, and this has negative slope, so down 1 to go right 2. So down 1, right 2. They share that point. Down 1, right 2. There's my two lines. So I can see that they both shared that single point in common right here, and that solution is at 2, 3. All right, stay tuned for part 2, and we'll look at a couple more.